No mammals ruling the Earth, no cities, no telescopes, no one watching this video, because 66 million years ago, a 6-mile-wide rock, traveling at roughly 45,000 miles per hour, slammed into what's now the Yucatan Peninsula and ended the 165-million-year reign of the dinosaurs in a single afternoon. It is, without exaggeration, the single most consequential few seconds in the history of complex life on Earth. But what if it missed? Right before impact, dinosaurs weren't dying out. They were thriving, diverse, adapting, spread across every continent, including underwater-adjacent coastlines and polar regions we don't usually picture them in. Triceratops grazed in herds. Tyrannosaurus hunted at the top of the food chain. Smaller, feathered dinosaurs were already evolving in distinctly bird-like directions. Some paleontologists argue the line between dinosaur and bird was already blurring by this point. Mammals existed too. They'd existed, in fact, for almost as long as the dinosaurs had. But for over 100 million years, the deal had been the same. Dinosaurs held every major ecological niche worth having. The large herbivores, the apex predators, the mid-sized omnivores, and mammals were squeezed into what was left. Small, mostly nocturnal, built for hiding, not competing. This wasn't a temporary phase mammals were about to grow out of. There's no fossil evidence of mammals on the verge of a breakthrough. As far as the paleontological record shows, that arrangement could have continued indefinitely. Then, an object from beyond Earth changed the terms completely. Here's what actually killed them, and it's more complicated and more interesting than an asteroid hit and everything died. The impact itself lasted seconds. The extinction took years. The asteroid vaporized bedrock instantly, launching an enormous plume of pulverized rock, sulfur, and soot into the upper atmosphere. Within hours, that debris was raining back down worldwide as superheated particles, hot enough in some models to ignite wildfires across entire continents simultaneously. Then came the part that did the real damage, the aftermath. Sunlight-blocking particulates lingered in the atmosphere for months, possibly years. Photosynthesis, the base of almost every food chain on Earth, collapsed. Plants died first, then the herbivores that depended on them, then the predators that depended on the herbivores. Ocean ecosystems collapsed in a similar chain as plankton populations crashed and starved everything above them. By the time the dust settled, literally, roughly 75% of all species on Earth were gone. The pattern wasn't random. It hit large-bodied animals hardest, anything roughly over 25 kilograms, since large animals need consistent food supplies that a multi-year collapse simply couldn't provide. Without that asteroid, none of this happens. No debris cloud, no sunlight blackout, no food chain implosion, no sudden emptying of ecological space. And that emptying is the actual hinge point of this story. Extinction doesn't just remove species, it removes competition. Mammals didn't outcompete dinosaurs in open combat for territory. They inherited a planet after the dinosaurs were simply gone. Within about 10 million years afterward, a blink, geologically speaking, mammals diversified explosively into every niche dinosaurs had vacated. Large herbivores, apex predators, and eventually small tree-dwelling primates. Take the asteroid away, and that vacancy never opens. Dinosaurs likely keep occupying those niches for millions more years because nothing forces them out. Mammals stay small, marginal, nocturnal, doing exactly what they'd already been doing successfully for 100 million years. Primates, in particular, may never get the evolutionary room or the evolutionary pressure to specialize into anything resembling us. So what would that world actually look like tens of millions of years later? Non-avian dinosaurs, given tens of millions more uninterrupted years, would almost certainly have kept diversifying rather than staying frozen in their late Cretaceous forms. Some paleontologists speculate about larger-brained, more socially complex descendants of small predatory dinosaurs, filling niches we associate with intelligent mammals today. Not humanoid dinosaurs. That's more science fiction than science, but a genuinely different evolutionary trajectory for intelligence on Earth, one shaped by reptilian ancestry rather than mammalian. Meanwhile, Our own lineage, the branch that eventually produced primates, then apes, then us, may simply never get the ecological opening it needed. Evolution doesn't move toward intelligence as some kind of finish line. It moves toward whatever survives and reproduces in the niches available. Without an available niche, there's no pressure pushing small, nocturnal mammals toward anything larger or more cognitively complex. In this version of Earth, dinosaurs aren't a chapter that ended 66 million years ago. They're still the main characters right now. This is the uncomfortable part of the story. Intelligence, as far as we can tell, didn't have to win. It got a vacancy. Every major evolutionary opportunity in Earth's history has followed this same pattern. Mass extinctions don't create winners so much as they clear the board and let whoever's left compete for what remains. The Permian extinction did it 252 million years ago, wiping out roughly 90% of species and clearing the way for the first dinosaurs to rise. The asteroid did it again 66 million years ago, clearing the way for mammals and eventually us. It raises an uncomfortable question for anyone hoping intelligence is somehow written into the fabric of evolution. On a planet that ran this exact experiment for over 165 million years, intelligence in anything like the human sense never once emerged in dinosaurs. It took a planet-altering catastrophe and 66 million more years afterward for it to show up in mammals at all. So the next time you look up at the night sky, remember, it isn't just stars up there. Somewhere in that darkness, 66 million years ago, was the exact object that had to arrive at the exact angle, at the exact moment for the entire experiment to reset, and for you to exist at all.